Okay, now I want to do some comparative statics. One comparative static we could think about, well, let's think about changing the costs, the marginal costs. Shift it down to lower costs, shift it up to raise costs. So that would be one experiment. We could shift the demand curve in the quantity dimension, the way I've done here. See, when I say vertical arrows shifting in the price dimension, or horizontal arrows shifting in the quantity dimension. I could shift demand in a price dimension as well. In fact, that's what we're going to do here in a minute. So algebraically, what I mean, remember we said m equals e prime? What I'm doing is sticking in a term there, additive, and saying, well, what if I add something to the marginal rate of substitution? That's a comparative static to think about, well, what if this guy were more willing to pay for the product or less willing to pay? You did that on a few homeworks, right? Like I think in the Edgeworth box homework, you guys said, well, what if the guy was more willing to buy up toward that corner than toward another corner? It's the same exercise we're doing. So let's shift the demand curve. Start at some point, I don't know, we'll call it 2019 and 2020, whatever you want to name the 2 points. We're going to shift demand, shift it up or shift it to the right, however you want to look at it. I'm going to express it algebraically in the price dimension. I'm going to shift it. And a comparison I want to make is, well, what's going to be the equilibrium quantity, the new equilibrium quantity, compared to what it would be if the price hadn't changed? The marginal cost had stayed the same. Okay, so let's do that. Actually, let's start at the bottom here and then we'll go to the top. This is the effect on quantity of shifting up the willingness to pay by dm. I'm making it a proportional shift by dividing by p. So this is a proportional shift in the willingness to pay, upward. What's the effect on quantity? Well, if the price were unchanged, it's based on the elasticity of demand. How much does a vertical shift translate into a horizontal shift? You multiply the elasticity of demand. But that's not our model. Our model has the marginal cost responding, so we get an extra term. And I'm going to highlight that in red. We got an extra term. Remember, all these are negative. So this is a negative minus a negative. That's a overall positive in the numerator. Since we have the single intersection case, this is going to be positive, and it's going to be bigger than 1. So we have a multiplier, if you will, not a heterodox multiplier like they have in macro. It's a multiplier in that shift in demand, of course, makes more quantity, but it also moves us down the supply curve, which further increases the quantity. So that's the sense in which we have a multiplier here. So that's one result that we have. Another finding is that quantity and price, or if you want to call it marginal cost, quantity and marginal cost, they're not going to go in the same direction if you're only shifting one of the curves. You pick a curve, I don't care which one, shift it, quantity and price are going to go in opposite directions. It's pretty tough to make the quantity and price to go in the same direction. You can do it, you're going to have to shift 2 curves, and you're going to have to shift them in the right amounts to make them move in the same direction. So the other side of that coin, it's going to be hard, if you're looking at data on quantity and prices, it's going to be hard to know whether demand or supply shifted. You're going to see quantity and price going in opposite directions an awful lot. And if you kind of didn't consider what we're talking about today, you would say, oh, clearly there had to be a shift in supply because quantity and price are going opposite directions. But no, that can happen with the shift in demand as well. And I'll show you some applications where that's been confused. The other finding that we'll have is this multiplier's not a constant. I said it can be greater than 1, but it'll tend to be close to 1, kind of near the ends. There's kind of a range. Maybe I should go back to one of these pictures. You know, out here to the right, supply curve is pretty flat. You're not getting much of this multiplier effect. Demand shifts, yeah, they push down the price, but not much. Therefore, there's not much feedback. Same thing way over to the left, supply curve is pretty flat, not much feedback. But you have this range in the middle where you get a lot of feedback. So that's another, in these type of human capital problems, that's another thing we expect there to be a range of high response surrounded by a range of lower response. So that's a few results we have. Again, we're just in the single intersection case. What I've done here is made a little table and say, okay, I don't know how elastic supply is, how elastic demand is, but let's compare their elasticities. Supply has to be more elastic than demand to have a single intersection. So that's why my table does not go below 1. But it goes from 1 to infinity. And you can see the multiplier can range from 1 to infinity. So the multiplier can be close to 1, or it can be quite large. Meaning you just get a little shift in demand. That makes a price response. And people are sensitive to prices, so that feedback is pretty strong. So here's an